In a discovery that has amazed astronomers around the world, scientists using the James Webb Space Telescope have identified what appears to be a supermassive black hole racing away from its galaxy at an unbelievable speed of more than 4 million miles per hour. This discovery is extraordinary because black holes are usually associated with destruction. Their gravity is so strong that they consume gas, dust, planets, stars, and even light itself. They are often described as cosmic monsters that swallow everything nearby. But this newly observed black hole seems to be behaving in a completely different way. Instead of simply destroying matter, scientists believe this black hole is actually helping create new stars as it moves through space. The black hole appears to be plowing through enormous clouds of gas that exist between galaxies. As it moves, its gravitational force compresses the gas in front of it. When gas becomes compressed and cool enough, it can collapse under gravity and begin forming stars. Behind the black hole, astronomers observed a gigantic glowing trail filled with newborn stars. This stellar trail stretches for more than 200,000 light-years. To understand how massive that is, the entire Milky Way galaxy is smaller in diameter than this trail. In other words, the black hole has left behind a structure larger than our own galaxy. Scientists believe this runaway black hole may have originated during a violent collision between galaxies. When galaxies merge, the supermassive black holes at their centers can interact gravitationally in chaotic ways. Sometimes, a third black hole enters the system, creating a gravitational slingshot effect that ejects one black hole outward at incredible speed. Researchers think that may be exactly what happened here. The discovery was led by astronomer Peter van Dokkum and later confirmed using observations from the Hubble Space Telescope. What makes this finding so important is that it challenges long-standing assumptions about black holes and galaxy evolution. For decades, scientists viewed black holes primarily as destructive objects. They were believed to suppress star formation by heating surrounding gas or consuming it entirely. But this runaway black hole appears to be doing the opposite, compressing gas and triggering the birth of stars. This means black holes may play a much more complicated role in shaping galaxies than previously thought. The discovery also raises fascinating questions. Could runaway black holes be common in the universe? How many galaxies have lost their central black holes? Could some isolated star clusters actually be trails left by ancient black holes? And could black holes help build new galactic structures instead of only destroying them? The James Webb Space Telescope was originally launched to study the first galaxies formed after the Big Bang. But it continues to uncover phenomena that scientists never expected to see. With its powerful infrared instruments, Webb can detect faint cosmic structures hidden behind dust and enormous distances. This capability allows astronomers to observe events that older telescopes could barely detect. Many scientists believe this discovery is only the beginning. As Webb continues exploring the cosmos, it may reveal even stranger phenomena that could transform our understanding of the universe. This runaway black hole reminds us that space is far more dynamic, violent, and mysterious than we once imagined. Even the most feared objects in the universe may sometimes become creators instead of destroyers. Another breathtaking discovery from the James Webb Space Telescope involves one of the most violent galactic collisions ever observed, a system known as ARP 220. Located approximately 250 million light-years away, ARP 220 is considered one of the brightest and most energetic galaxy mergers in our cosmic neighborhood. Scientists believe that around 700 million years ago, two giant spiral galaxies collided in a catastrophic event. The collision triggered an enormous burst of star formation and transformed both galaxies into a chaotic system overflowing with energy, gas, dust, and exploding stars. Today, ARP 220 shines with the energy of nearly 1 trillion suns. By comparison, the Milky Way galaxy produces the light of roughly 10 billion suns, making ARP 220 vastly more luminous. At the center of this merger lies an incredibly dense region measuring only about 5,000 light-years across. Yet despite its relatively small size, this area contains as much gas and matter as the entire Milky Way galaxy. Previous observations using radio telescopes had already revealed more than 100 supernova remnants concentrated within a tiny region of space. This indicated that stars were forming and dying at extraordinary rates. However, thick cosmic dust prevented visible light telescopes from seeing the true structure of the merger. That changed with Webb. Because the James Webb Space Telescope observes the universe primarily in infrared light, it can penetrate dust clouds that block ordinary telescopes. Using its advanced instruments, Webb captured the clearest and most detailed images ever seen of ARP 220. The images revealed two brilliant galactic cores separated by roughly 1,200 light-years. Each core contains rotating rings of intense star formation. Webb also detected long tidal tails stretching outward from the galaxies. These tails are streams of stars and gas pulled outward by gravity during the collision. They provide visual evidence of the enormous gravitational forces involved in galactic mergers. One of the most fascinating discoveries was the presence of glowing red and orange filaments rich in dust and complex organic materials. These structures reveal how chaotic and chemically active the environment has become. Astronomers consider ARP 220 a cosmic laboratory because it allows scientists to study processes that shape galaxies over billions of years. By observing this merger, researchers can better understand how galaxies grow through collisions, how supermassive black holes evolve, how starburst events occur, how cosmic dust and organic molecules spread through space, and how the early universe may have looked billions of years ago. Galactic mergers are among the most powerful events in the universe. Over time, they can completely transform galaxies, changing their shape, structure, and behavior. Scientists believe even our own Milky Way galaxy will eventually collide with the Andromeda Galaxy billions of years in the future. By studying systems like ARP 220, astronomers gain a glimpse into what such future cosmic collisions may look like. The discoveries made by Webb continue to revolutionize astronomy. With every new observation, the telescope reveals a universe filled with violence, creativity, mystery, and beauty on unimaginable scales.